Hey. Oh, only a few of you. Boy, I hated it.
I did.
There you go, Spencer. I would much rather have been
We
in.
lost a day of vacation for less snow than we had already.
Right? Unbelievable. But it is what it is, and
You still have 4 days of vacation, 3 days of vacation.
I believe it's 4.
4.
But it is what it is, and we just got to keep pushing forward. Hopefully, the biggest reason that I really wanted to be home is that I do think Zeba's pregnant, and then I do think I'd rather be home with the puppies for an extra day than be home dealing with snow. So, anyway, let's get started going over today's quiz. Everybody got their quiz out? We're getting more hundreds. This is the second in a series, and we also missed school yesterday, so we missed a little of that rhythm. But I do think we should have done a little bit better than we did. So let's see if we can straighten out any remaining mistakes here. On the first one, the roots are 5 and 6, or the zeros are 5 and 6. Zeros, roots, same exact thing. And remember, we always reverse the roots when it comes to what the factors had to be. So if the roots are 5 and 6, I needed to reverse them in the parentheses and get x minus 5 and x minus 6. The answer is choice 4. I believe every single person in the room, Sarah E., got that correct. Then we went to number 2, and virtually every person got number 2 correct. So we're looking very good on this one as well. We have a parabola. Its vertex is 2, negative 1. Then we wanted to translate this or create a new parabola, which would be the old parabola minus 3. That is to say, every x-coordinate would be moved 3 units. And in this case, we reverse in the parentheses, just like in the previous question. Always reverse in the parentheses. This would be 3 units to the right, because it says minus 3, and we reverse in parentheses. If I shift 3 units to the right from 2, negative 1, I get to 5, negative 1. And again, virtually every person got that right. Yes?
You marked me wrong for number 3 when I was right.
Okay, show it to me in a couple of minutes, and I'll go over it, all right? Lord knows. I don't think I made a Linquist Daily dumb mistake today. I think I was going to on number 3, but I graded Anthony's early on and saw that I was about to make a mistake, so I corrected it. So that could substitute for my Linquist Daily dumb mistake, the mistake grading your paper. All right, so now let's go to number 3. And this is really where we are beginning to have some problems. And we've only been going over sequences for about 3 days now, and we absolutely need to get better at them, okay? What's the 25th term of this sequence? So look, there's a couple of ways to do this. Forget trying to remember formulas for just a minute. Just turn on your brain. Use your math thinking skills. What's happening here, every single time, I wrote minus 4. That's because I did it in the original one. It should have been plus 4 every single time. I'm going up by 4s. If I'm going up by 4s, how many times am I going to go up by 4? I'm not going to go up by 4 25 times. How many times am I going to go up?
24.
How come 24 and not 25? Spencer?
Because 7 is in plus 4.
Right, I don't need to add 4 to get to the first term, namely the 7. So I always subtract 1. That's why it's 25 minus 1 here to get 24. And then I do 4 times 24, which is 96. And then I add in the first term, which was 7. And 7 and 96 make 103. Now, that's one way to do it. But there's an entirely different way to do it. And different people like to learn different ways. Nobody's better than the other. Personally, I like to do it the way I wrote it over here on the left. But some kids are very methodical, and they like to have formulas, and they like to work within the structure of a formula. For those kids, the formula is always that the nth term, f of n, and you could also write a sub n, is a sub 1, which is known as the first term, plus the common difference, d, times n minus 1, which is the number of terms minus 1, and we just said y, because we don't need to add the 4 to get to the first term. If I use that formula, notice that's exactly what I did here. So without ever knowing the formula, I did the formula, and that shows excellent mathematical thinking. First term is 7, common difference is 4, 25 minus 1. Obviously, it works out to the same 103. Any question on this? All right. So now let's go to the 10th term in this sequence. Now we are multiplying by 3. You know, sometimes they say, what's the 5th term? Well, then I could just do 135 times 3. But when they start saying the 10th or the 20th or the 120th, then Sarah E. It is a stop with the bottle. Then what happens is it's just a lot easier to look at the pattern, to see a formula being formed here. In this case, the common ratio, because this is a geometric sequence, is 3, 15 divided by 3, 45 divided by 15, and so on. Again, I'm going to do it n minus 1 times because I don't need to do it to get to the first one. So the 3 will be to the 9th, times 3, times 3, times 3, times 3. That's exponentiation. So that's 3 to the 9th. And then I'm going to multiply by the 5 that started the whole thing off. And when I crunch those numbers, I get 98,415. Now, one of the things about these quizzes that I've said so many times this year is it constantly teaches me what you don't know and how my assumptions are wrong about what you do and don't know. It's really eye-opening if you're the person who teaches the class. I would have thought that virtually every person, let's say 80 to 85% of you would have gotten number 3 right, and that more of you would have gotten number 4 wrong than got number 3 wrong. And actually, more people got number 4 right than number 3, which, again, surprised me. I didn't expect that to happen. Okay, any other questions on your quiz? All right, so now let's go to, we'll do it in a couple of minutes. Let's take a look at last night's homework. I guess no one checked the homework today, which means someone's going to have to double check tomorrow. All right, I'm going to stop talking for a minute. I'll scan through the homework answers. I'll bring up a couple of points of emphasis from my point of view, but compare your answers to this, and if you have a question, pop your hand up. Good opportunity to reflect on your work here. Yes?
Could I have a tissue?
Sure.
Okay, great.
Remember how incredibly important it is to be excellent at factoring in quadratic equations. I have not yet gotten back the relearn package from photocopy. I expect them later today or early tomorrow, and I will give them to you tomorrow. Yes?
I don't understand how you got x equals -1 on letter C.
All right, this could be the Lindquist daily dumb mistake. Let's see. Distributing 6x minus 15 plus 2x is 5x minus 18. This is the same size situation. Put them together, I get 8x. Minus 15. Oh, yeah.
I got 10.
Oh, look at that. No, I'm doing okay.
Wait, where's the plus 2x?
Yeah, I got
Oh, you got it.
I added it together. That's 8x minus 15 is 5x minus 18. Now I have an opposite side, opposite operation situation. I minus the 5x from both sides. I get 3x. Minus 15. That looks like plus 5, but it's minus 15. My handwriting's awful. Is negative 18. I add 15 to both sides. I get negative 3. And then I divide by 3.
I don't know what I did. I thought that I got for the first equation 8x minus 15 plus 2x.
Oh, I think you did the 6x and the 2x in your head, got 8x, and then rewrote the 2x.
I think so, yeah.
Yeah, that's a very typical mistake that I would make. That's a classic Mr. Lindquist mistake. Any other questions as we go through here? Number 2, the quadratic formula. One of the areas that we do need to get better at is simplifying radicals. I'm going to do a lot of work with that a little later in the homework here, okay? The factoring, so important. Guys, oh, Lord. You know, first off, I want you to know you're normal. Second off, I want you to know that it shouldn't happen. If we take a look at the factoring on 3A, that should be the easiest factoring on the entire page by far. When you cross the road, what do you always do? When you factor, what do you always do?
Look for a common.
Look for the common factor. But people go right to double packages. Look, just look for the common factor. It's a V. Pull it out. 3V minus 4. Done. Yet on the test you took last week, no one should miss that. That's the easy one. Yet on the test last week, a lot of people missed it. So we have to be aware of that. It doesn't mean we're not smart enough to get it right. It means in our priority system, we're just cutting right to the double packages all the time. We're skipping the first step. If you don't look both ways before you cross the road, there's a pretty good chance eventually you're going to get hit by a car. And there's a pretty good chance when you factor, if you don't look for the common factor first, you're going to get smushed like roadside pizza. So we can't let that happen, all right? All right. Now, let's go to number 4. Again, here's the same formula we wrote out before. The key to understanding here, the top highlighted stuff, the whole key to understanding sequences is in your ability to read the ability to read the mathematical jargon. A sub n means the new term. It's really the nth term in the sequence, but when you compare it to the next thing written, this means the new term is the previous term minus 5. And then it tells us the first term is 12. So I start with a 12 and I apply the rule, minus 5. I minus 5 every time. 7, 2, negative 3, negative 8. Then it wants an explicit formula. Well, that relates to what we did on the quiz. Look, I don't need to go down 5 to get to 12. So I start with the first term. I go down 5, whatever term I'm looking for, minus 1, because I didn't need, God bless, to get to the first term with the minus 5. So f of n is 12 minus 5 times n minus 1. I could also say a sub n equals, it's the same thing. And I always, you know how when we factor, you're supposed to do a quick mental check to make sure your factoring is correct? And the whole class said,
Sure.
can I get a witness?
No.
No, I want to hear some volume on this. Come on, let's go. When you do factoring, aren't you supposed to do a quick mental check every single time?
Yeah.
Absolutely, very good.
That's a possibility.
Yes, that's linguistis. So now I'm going to check my fifth term, and I'm going to make sure I get my fifth term in the sequence right here. So if I plug in a 5, 5 minus 1 is 4, negative 5 times 4 is negative 20, 12 minus 20 is negative 8. Bam! I got it right! All you need to do is quick mental check. Okay? You could also use the formula 17 minus 5n by relating it more to y equals mx plus b and backing up a term. We talked about that the other day. All right? And then it says here, find the sixth term. That one I just went down another 5. And then find the 100th term. And I plugged in the numbers and crunched it. Okay? Now, simplifying each radical expression. This is the next topic that we have had difficulty with from the last test. The first thing we had was sloppy factoring. Not unintelligent factoring, sloppy factoring. No quick mental checks, no looking for common factors. The second thing is that we need to simplify each radical expression. And we have discussed the importance of, before we attempt to simplify radical expressions, writing out the list of perfect squares, which is highlighted there for you. And your job then is to look for the biggest perfect square that divides into each of these radicals. And remember, we got rid of the variables the other day. You just keep getting rid of them. And you'll notice as you look through, for instance, on this list, the biggest perfect square that divides into 300 is 100. So I do 103, square root of 100 is 10, 10 radical 3. Some people like to put square root of 10 here. That would be a mistake. When you square root 100, you don't get square root of 10. You get 10, because 10 times 10 is 100. Think of it as I applied the radical to get to the 10. Since I applied the radical, it's no longer there. AJ.
For B, where'd the negative sign go?
Oh, ding, 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 ding. What did we just find, guys? Linguist daily dumb mistake. Very good. I should have a negative 5 there. Okay, any other? I'm just going to leave that for a second. Just take a look over it. Any questions? Jay now?
You said there's going to be a negative start in front of the 5. What's going to be between the 5 and the radical 5?
Nothing.
Nothing?
Nothing. No symbol between two things means to multiply, and that's what I'm doing here. There's no symbol here on multiplying, so there's no symbol here.
Oh.
All right. Next up, I think it's this one. Yes. You don't have to do these. We talked about that the other day. Now, Fibonacci sequence. I'm running a little short on time. Let's go down to this very quickly. Arithmetic or geometric. I'm adding the same thing over and over again, so it's arithmetic. I am multiplying, so it's geometric, adding arithmetic. These are the same formulas we just spoke of at length a couple of minutes ago. And then these are here. On our test the other day, we did very well at realizing that this is horizontal shift. It's 7 to the left. This is vertical shift. It's down 1. This stretches it up or makes it taller or more narrow. They tend to use the word narrow on the Regents exam. But I want to talk about the Fibonacci sequence, and sometimes in the world, we are just much better off hearing different voices. So I'm running a little bit behind where I want to be, but let's go with this.
Wait.
The sequence begins with the numbers 1, 1, 2, 3, 5, 8, 13, 21, 34, and continues indefinitely. Each number is obtained by adding the last two digits together. If we were to take a perfect or golden rectangle, break it down into smaller squares based on Fibonacci's sequence, and divide each with an arc, the patterns begin to take shape. We begin to see Fibonacci's spiral. The spiral in and of itself is insignificant. Its importance is revealed in where we find it. Take, for example, the sunflower. The display of its florets are in perfect spirals of 55, 34, and 21, the sequence of Fibonacci. The fruitlets of the pineapple create the same spiral based on the sequence. The pine cone does the same. As currents move through the ocean and the tide rolls onto the shore, the waves that bring in the tide curve into a spiral that can be mathematically diagrammed onto a plot at the points 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. Buds on trees, sand dollars, starfish, petals on flowers, and especially the nautilus shell are formed with this exact same blueprint. With each segment of growth, the nautilus adds to itself one more value on Fibonacci's scale. This blueprint can be seen around us on a small scale every day, but the greatest example of all is directly above our heads. At an average of 100,000 light years across, even the spiral of the galaxies above us are formed with the exact design that the tiny shell is formed. This sequence, or blueprint, appears to be the trademark of a designer.
Oh, yes. Everybody likes to say that the scientific law of entropy says things tend to disorder. And this, I think, certainly mentions a certain sense of order in the universe. All right. So anyway, let's get to today's lesson. And we're a little short on time, so we have to go fairly quickly through today's lesson. Oh, you know what I need to do before that? I have the answers to the do it. Oh. Here's the answers to today's do it. Take a quick look. I will give you about 30 seconds to look them over, and then I have a short lesson to give. Okay? And again, if you have any difficulties with this, if this is driving you crazy in any way, shape, or form, you have the video at home to watch, to catch up on. I'll be at Extra Help tomorrow morning. And then Monday, Wednesday, Thursday next week, Tuesday at the library. All right. Let's start talking about interest. And today is not the only day we're going to talk about interest. We're going to talk about interest as well a little later. First off, this is the only guaranteed way to get rich or get broke in the history of the world. You get broke by spending money you don't need to spend, but you can get rich or broke by following this formula. This is the formula for compound interest. This is why credit cards are evil. It is also why if you put money into long-term savings and compounded interest, you will one day have a lot more money than you thought you would have. All right, so let's take a look at exactly why. Kira's been babysitting since 6th grade. She saved $1,000, wants to open an account at the bank so that she will earn interest on her savings. Simple interest pays at 10% a year. How much will she have after, let's go 5 years, all right? Simple interest is what you covered last year. It's I equals PRT. The interest is, the amount of money is principal, that's what you start with, that's 1,000, times the interest rate, which is 10%, so 0.10, and we're gonna leave it in there for 5 years. That would be 0.5 times 1,000, and 0.5 times 1,000 is 500. And just so that we could say what's in the account, it would be the original 1,000 plus 500 more. How much is total in the account?
1,500.
1,500. Very good. That's, again, you covered that last year. That's pretty simple. We are now going to do compound interest, which is this formula right here. Okay, Raul takes $200 to start a snow cone. How much will he have after 5 years? So here's your difference. We're not going to do simple interest, all right? Scratch simple interest. Oh, let's scroll down to Jack. He's investing 500 bucks. The rate is 6% compounded annually. Let's do 10 years and see what it makes. So, the first thing is, the compound interest formula uses A for the amount in the account. You don't get the interest. You start with the amount you start with, which is 5,000. Then you're going to do 1 plus the rate of interest as a decimal. 6% as a decimal is what?
0.06.
0.06. And then times the number of years, which is 10. So that would become 500 times 1.06 to the 10. Can somebody hit that on their calculator, please?
Wait, isn't it rate divided by number of years?
No, that would be if it was like compounded monthly and stuff.
Okay.
Since it's years, we go with exactly what it is. So let's do 500, somebody on that calculator, please, times 1.06 to the 10.
530.
How much is it?
530.
530, that's it?
Yes.
You sure about that?
I got 890.
500 times 1.06,
I got
right?
895.
895. Point what?
423.
423. Now, this is
I
money.
did not see that.
All right, this is money, so money always gets rounded to the nearest hundredth. So it's $895.43. $895.43.
That's after 1 year?
That would be after 10 years.
That's
Let's
10
do
years.
something, yeah, let's do something really quick, and if the bell rings, hang with me on this, because it's worth doing. Let's say you make $3,000, and you put it in your bank account, and you're gonna leave it there at 10% interest, which is possible to find, so it's 1 plus 0.10, and let's say you leave it in there from the day you turn 18 until you turn 60 years old. That would be left in there for 42 years. Let's see how much the 3,000's worth. This is how you get rich, folks.
32
Oh, I
years?
got it.
Do 3,000 times 1.1 to the 42nd power.
164,291.
$164,291, and then round off. 3,000 becomes 164. It is the miracle of compound interest. All right? Tomorrow, we'll do a lot more work with compound interest. Today was getting your feet wet. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Rizzain. Adios, amigos y amigas. Perushinus. Kitafes. Shalom. Is it an A day? Is it an AJ day?